All right, we're going to start with the video for the organic chemistry unit on just an introduction to organic chemistry. This is part of chapter 25, which starts on page 1050 in your textbook. And this particular video is going to just cover the introduction section 1 information. While you're watching this video, please take notes in your notebook. Please also feel free to pause or rewind it if the information goes by too fast. And if you need to get more information or you don't understand something, you should be reading the section in your textbook to follow along. So we'll start with an introduction to organic chemistry. Organic chemistry is the study of any compound that contains carbon. And those of you that have taken IB biology have also studied a little bit more in depth to something called biochemistry, which is the study of living compounds, or living systems, excuse me. However, when we focus in chemistry, IB Chem, on organic, we are going to focus on things that are involved in living systems and as well as things that are not, like fuels. Remember that you learned last year that shapes of molecules are important in determining what kind of physical and chemical properties those compounds will have. And that's no different with organic molecules. And the reason that this is especially important is because carbon has the ability to make several different shapes. You might remember last year that you've learned some of these shapes that carbon can make. The reason it can make so many shapes is because it has the ability to make single bonds, double bonds, and triple bonds. When carbon is making 4 single bonds, it is considered tetrahedral in shape, and those bonds are living in sp3 hybrid orbitals. When carbon is making 1 double bond and 2 single bonds, now the shape is considered to be trigonal planar, and it's got sp2 hybrid orbitals. Lastly, carbon can be linear in shape, and it can do that by making either 2 double bonds or 1 single bond and 1 triple bond. In those cases, that is linear and it's sp hybridization. Now, if hybridization seems a little bit fuzzy to you and you don't remember talking about it last year, there is a handout in our Moodle page that is called VSEPR, Molecules and Shapes, so you may want to look through that. To continue on with organic, we're gonna learn as this whole unit continues that the properties of organic compounds vary greatly from one to another, and we can change the properties by adding something called a functional group. So usually it involves removing a hydrogen and adding something like an oxygen or a group of atoms like carbon, oxygen, and hydrogen, or nitrogen, and in doing so, that will change the properties of the compound. It could also be that the functional group is just changing a single bond to a double bond or a triple bond. In doing those things, the functional group will change the chemical reactivity, it can change the solubility of the molecule, and it can change whether or not that molecule is going to act like an acid or a base. And in many organic compounds, some of them, if they're very large, will have one end that can act like an acid and another end that can act like a base. In biology, we call those kinds of compounds amino acids. So we'll talk more about those as we go through this unit. Now, today what I want to focus on is hydrocarbons, because over the next few days we will be learning how to name basic hydrocarbons. Obviously, hydrocarbons are compounds that contain only hydrogen and carbon. There are 4 types of them. The first type is called an alkane. An alkane contains only single bonds, and they are saturated. Saturated means they're making as many bonds as possible for each atom. All alkanes will end in an ane suffix, so things like methane, ethane, propane, butane, pentane, etc. are all compounds that contain only single bonds. The next set of compounds is called an alkene. An alkene contains at least 1 double bond between the 2 carbon atoms. Those are considered to be unsaturated compounds because they are making fewer than the maximum possible bonds. So an unsaturated compound could be an alkene, which contains at least 1 double bond, and all alkenes will end in an ene suffix. Or it could be an alkyne. An alkyne will contain at least 1 carbon-carbon triple bond. those are also to be considered unsaturated. And all alkynes will end in a YNE suffix. The last type of hydrocarbon that we will study is a group of compounds called aromatics, and all aromatics will contain a benzene ring structure. And we will talk more about those as we go through them and name each of these 4 categories. So that's a brief introduction to the types of compounds. And then if we look at one set of compounds in particular, they can create what we call a homologous series. Now, a homologous series is a series of compounds that all will either have the same functional group. For example, it could be that they're all alkanes, they could all be alkynes, or they could all be alkenes. It doesn't really matter, but they could all be alcohols. They will all have the same general formula. In the case of an alkene which has a double bond, the formula would be CnH2n, but in an alkane, we would have more single bonds being made, so CnH2n plus 2. If you have a series of these compounds, all having similar formulas, they will also have similar chemical properties. So an example, these are a series of alkanes, CH4, followed by C2H6, then C3H8, C4H10, C5H12, and we could keep going. That's following the same general format up here, CnH2n plus 2. All of these compounds would have very similar chemical properties, but as you increase from one compound, like from CH4 to C2H6, they're getting heavier. And as you continue through that series, each of the molar masses is going to increase. So therefore, their intermolecular forces, which are London dispersion forces, are also going to increase. And as a result, all of these boiling points will get higher as you move down the series. That can affect what kind of physical state you will find them in at room temperature. For example, methane is a gas at room temperature. It's what we use to light our Bunsen burners. But as we get down to the heavier compounds, they will become liquids at room temperature, and even the heaviest ones will become solids. So that's our introduction to organic chemistry. And again, if you need to rewatch this or pause it along the way to take notes, feel free. And we will start learning how to name the different organic compounds later in this unit.